ACM India has been organizing annual flagship events to discuss trends in science and technology and to celebrate ACM spirit. ACM Annual Event 2016 is pronounced by its rich encompassment of deep personalities far and wide. Now, I call upon stage Dr. Samuel Kambi, ACM Trivandrum Chapter Chair, to deliver welcome address.
Good morning, respected dignitaries of class, distinguished participants, ladies and gentlemen. I extend a warm welcome to one and all to ACM India Annual Event 2016. ACM India Annual Event 2016 is hosted by ACM Trivandrum Commercial Chapter in association with the Indian Institute of Information Technology and Management here at Trivandrum. So it is very fun to know that today's event is manifested by the esteemed representatives of prestigious personalities including Dr. Edward Albert Trivandrum, a pioneer in the field of artificial intelligence and is often known as the father of expert systems. Dr. Jennifer Wilder, the French Brown's Professor of Computer Science and Electrical Engineering at Stanford University. Dr. Anders Dow, Professor of Logical Algorithms at the University of Cambridge. Dr. Alex Soul, President of the Association for Computing Nationally. Dr. Bhavishana, CEO, ACM. Dr. Srinivas Ranathan, President of ACM India. Dr. Aditya, Professor Maria, Professor Bhavishana, and so on. So I take this opportunity to welcome each one of you on behalf of ACM Trivandrum Chapter at Trivandrum University event. I hope you all will benefit from the forthcoming collaboration. Thank you.
Thank you very much, sir. Now, I invite Dr. Bhavishana, CEO of ACM, and Dr. Alex Wool, President of ACM, to talk a few words on ACM global perspectives.
Thank you very much, and welcome to this event. It's of course an honor and pleasure to be able to join you here. I've had the privilege of being at a number of these events now, and I can say that each year it grows in esteem and quality and enthusiasm, energy, and I'm just very, very proud of how ACM India Council and the local chapters have promoted computing and computing excellence in India. I just want to say a few words before I introduce the CEO of ACM. First, I want to point out that ACM is a volunteer organization. It's fundamentally driven by its members and the needs of its members, and through the efforts of volunteers. I'm a volunteer, I'm a professor, and so my time is donated to this, and I appreciate all the other volunteers, many of whom are in India, who contribute their time to advancing computing as a science and a profession. And I encourage you, of course, to take advantage of those efforts, but also to contribute to those efforts. The second thing I want to say is that the efforts of the volunteers are very much dependent upon and supported by a wonderful staff at ACM. And when our previous CEO retired, we had a very difficult task in finding someone who could share the values and share the commitment of our volunteers and members and of our staff. And our previous CEO had, in a sense, set the tone. He was from our community. He was a member of our community and a volunteer for many, many years. And so when we look for a new CEO, we also look for those qualities. And I think that ACM is unique as a professional society in having a leadership, a joint leadership of volunteers and staff who come from our community and understand our community. So I'd like to ask our new CEO, who just began in November, to come and give some words about ACM, where ACM is, and where ACM is going. Bobby Shaw.
Thank you, Alex. It's a great pleasure to be here. I think one of the requirements to be the new CEO of ACM should have been, among other things, is should be a person who loves to come to India, and I would have qualified on that one at least, because I love coming to this country. It's a real favorite of mine, and I'm delighted to be here. I've been in India many times. I've never been in Kerala until now, and so it's just wonderful to get to be here as well. And let me second what Alex said. Yesterday, again, as I was sitting in the room, first at the ACMW meeting, and then at the ACMW India meeting, and then the ACM India Council meeting, I was again struck by the fact that you see in every ACM volunteer-led meeting the quality of the people, excellent people who do wonderful things in their careers, who also give their time to lead these important events. So Arati led the meeting yesterday, Shirley Moss, and so many other people. Thank you very much. I'm just going to speak briefly, tell you a little bit about ACM and where it's going. So there are only 5 more slides, and the last one is the most important one. It talks a little bit about where we're going. I think you all know ACM is the world's premier professional organization in computing. It's the largest one, it's the oldest one, and is dedicated to advancing computing as both a science and a profession. ACM is evolving into an entirely international organization. It's still part way through that evolution, I would say, but even at this point, as you can see, ACM is a little over 40% membership in the United States, and then significant amounts of membership in China, in Europe, in India, and then many other nations of the world. I hope that as I keep coming back to India for these events, that percentage and that place on that list is going to just continue to rise. Although, as we talked about yesterday, ACM has to provide good reasons for people in India and everywhere else to want to join, and that's what our concentration is. As you can see there, the membership is a mix of professionals and students, And it's also a very even mix of people who are practitioners in the field and people who are researchers in the field. And while ACM has a very large number of members, 110,000 or more, it involves 2 to 3 million people each year who attend its events, who participate in publication programs in various ways, who access its content. So it actually touches a very large number of people. ACM is extensively involved internationally. By this point in its time, it has regional councils in India, which met yesterday, in Europe as a whole, in China, and as I talk about our plans, there's more of that to come. It also has chapters in every continent except Antarctica. If there's anybody from India who would like to organize a chapter in Antarctica, please talk to me. And chapters in 60 countries around the world. What you see the picture of there is the Heidelberg Laureate Forum, a forum that brings together the Turing Award winners and equivalents in mathematics to meet with students and young computer scientists each year in Germany. ACM presents a staggering amount of content to the world. It is the leading presenter of publications and conferences. As you see there, ACM has nearly 200 conferences, and if you count the workshops, nearly 500 conferences and workshops each year in all fields of computing. And virtually all of these have published proceedings as well. So you can see also there's 37 special interest groups. 3 of those groups have specific India parts as well. SIG Soft, KDB, and SIG-C, Computer Science Education. ACM publishes over 50 journals and magazines per year, and in 2015, as in 2014, well over 20,000 items were added to the digital library, which has nearly 500,000 ACM publications and access to about 2.5 million computing publications overall. So finally, where is ACM going? I think the most important statement to make, not only here but everywhere, is it is on the path of becoming a fully international organization. What does that mean? Not only an organization that represents computing professionals and researchers in countries throughout the world, but whose leadership, whose programs, whose conferences and events are distributed throughout the world. That happens already. For instance, I was just hearing about an application for the KDB conference, which is one of the really thriving conferences of ACM to be held in India in a couple of years. But this will continue to happen more. And I think as you look at ACM in the future, you will see a leadership, a set of conferences that are as international as we are as a group. The second thing I wanted to mention is that we are starting to try to do more to bring together the research communities and the entrepreneurial communities. In fact, there's an event that we will host, Alex and I will both be there in a few weeks in Silicon Valley to begin this conversation and think, how can ACM really add value there? One reason I want to mention it here is that in the last day I was able to start conversations with Srinivas and others about the possibility of doing the same thing in India, likely in Bangalore. And if we can do that somewhere within the year, I would hope that ACM can host the same thing and try to specifically concentrate on how we bring those two communities together in India. The last two things I want to mention are ACM plays a major role in trying to foster the diversity of the computing fields, the gender diversity, forms of other diversity that are specific to various countries. ACMW India is a very important part of that, and this continues to be a really important part of what ACM tries to do. And the final one is a challenge for all of us. Alex talked about it being a volunteer organization, so this is your challenge. This field evolves more quickly than any other field now or in history. And as much as we're all involved, it is a challenge for us to always reflect that evolution. Think of all the new things that have come up in recent years. The Internet of Things, big data, autonomous vehicles, smart cities. the list goes on and on. We really try very hard at ACM to make sure that our conferences, our workshops, our programs reflect that. And as you become leaders in ACM, that becomes your challenge to help us reflect the wonderful research and intellectual diversity of our field. So again, it's just a tremendous pleasure to be here. Great thanks to our invited speakers who made big trips to come here. And as you are, I'm very much looking forward to hearing from them as well. Thank you.
Thank you, sir. Thank you very much. Now, I invite Dr. Trivandrum, President of ACM India, to present ACM India report.
Good morning, everyone. Good morning. Good morning. Good. I think it's good to start with the low. Not a good idea to start with the low energy because there is a half-life, of energy as you go through the day, and we want to keep the energy levels high for all the high-powered talks we're going to bring to you. So, let me, without further ado, thank all the speakers who come here, all the organizers of the local Trivandrum chapter, and I would really like to thank the ACM India Council, the ACM Council, and all the invited guests, and most importantly, all the people who have come from all over India. I'm assuming a lot of them from Kerala, but I'm sure a lot of you have come from all the other places to listen to the divinities of computing. And I hope you have lots of questions for the speakers so that you can go back really enriched with a lot of knowledge. And we look forward to a very eventful day. And before I do that, I'm here to just briefly present a 360-degree view of what ACM Media has been up to, what activities has been up to, and towards the end, there will be 2 interesting awards we will be giving away. And let me start with the vision of ACM Media. ACM India will like to be the voice of the Indian computing community. Like it could be students, faculty, professionals, more specifically researchers, because ACM is a very strong organization. It fosters research and advancement of computing and science. And towards that, as you saw in the presentation of Bobby, we support a lot of upcoming conferences in marquee areas of computing, specialist groups in computing, and also provide support for hosting such conferences. This is the ACM India Council, which is usually a 2-year term, and we're going to have a new team very soon in the next 6 months. This particular event actually is the second day of a 2-part series, where yesterday we had a whole day of presentations by research scholars across India. We invited people who are in the advanced stages of their PhD to come and present their work. Some of them got an opportunity to present in a presentation format, others had a poster. And this was an occasion where all the PhD students got feedback from peers, from others who attended. This has been a tradition started some time back by Dr. Bala and Dr. Naveen. And we decided 3 years back that let this event IRIS, which is the forum for all research scholars in India, to come at one place and present the work and get reviewed and get feedback, and also let the world know what research is happening in computing in India. This is a great forum. I think we decided to give a helping hand, and since the Delhi event in 2013, we have been hosting it regularly along with the ACM India annual event. We hosted it in Delhi, then we did it in Goa, now we are in Trivandrum. So, going forward, this is an important contribution of ACM to the research fraternity in India in terms of bringing a new marquee event for the research students to showcase their work. Today is the annual event. We are going to have a series of presentations by luminaries in the field, including Dr. Feigenbaum, Dr. Trivandrum, and then we have Dr. Nizar. So just from numbers, this is a must-have slide because no slide is complete without numbers. Today, especially in the era of big data, we have to bring data and let data do the speaking. So I'll let data do the speaking, go over it for a minute. But important thing for you to understand is, in terms of the audience, equally important for us is the student community. That's why you see in this room, I think it's around 80% students. And we're happy to see this, see this audience. Thanks, Sabu and the local team for making this a well-attended event. I think you are giving a warm applause to all the students who come from all over India. So we hope we will remain very relevant for students, and a request, students who made use of these opportunities. I'll put a marketing page here. Please become ACM members. You will get a lot more. This is just one slice. It's a tip of the iceberg what you have got benefit. If you become members, you can get access to the latest happenings, latest outputs of research in computing. You can get access to the digital library, which is the largest compendium of computing research outputs. You can get to attend all these kind of events. You can form a chapter in your own college. You can invite experts from all over India and world to your college. So I think it's very important for you to first become ACM members, and then when you graduate, become ACM professional members. Continue that linkage with ACM. That's very important because what happens is many of you, I can tell you, are going into a job which is going to require deep computing knowledge. And deep computing knowledge, you have to have access to good source of original, latest, insightful knowledge. And that's what ACM provides you. So my request first is, if you are not a student member, become a student member. If you are a student member, after you graduate, become a professional member. That's important. So like that, we also like to look at the number of professional chapters and student chapters. We have close to 100 student chapters. We like to see the numbers grow. See if you're in your college, you don't have ACM student chapter. Work with people like Saul, understand what it means, get an application up and running. All it means is a couple of faculty members in your university becoming ACM professional members, and a couple of students, about 10 of them becoming ACM members. And then you can start a chapter of your own. It does not take a lot, and it is an important step you will have taken for improvement of your own college and your own career. The number of 6 chapters, this is basically, like this Bobby was mentioning, we have dominant chapters like 6SOF, 6KDB, and 6 CSC. We're going to look at launching more and more new 6. We have an increase in ACMW chapters. We have, as I said, ACM represents women in computing and would like to endorse women in computing and would like to promote women in computing to a large extent. So we will have actually a follow-up presentation of this by our team on what ACMW India is doing. Then we have an offering for chapters that they can host invited speakers in form of DSPs, distinguished speakers or eminent speakers, which ACM supports to visit the college. It's not that you have to bear the cost. So it's in your interest to look at becoming a consumer of this program from ACM. So open a chapter, get ACM, DSP and DSP program to help you get good speakers from all over the world and India to visit your college and let the students know how different advances in computing are happening via these talks. So that's what ACM India at a glance was. As I mentioned, one of the key constituents has been the research. So we recently constituted an ACM India Research Board under P. Narayan here. We are going to host the second faculty summit or research summit in this direction next week in Pune, India, along with Microsoft Research and Infosys, where we're inviting major research heads, either at institutions or at labs, to come together, brainstorm on what is needs to foster research in computing, take it to higher levels. We're already hearing instances of shortage of number of research skilled graduates, PhDs in computing available for academia and industry alike, because today's industry needs are very high tech. Today, if you talk about big data company, we need PhDs in machine learning. We need PhDs in databases. We cannot live with just resting on our laurels of having just an undergraduate degree. It's a good idea for all of you to plan for a degree in PhD. And towards that, they've been working hard to get together a sense of community among researchers. So one of the first things that we're doing, along with the hosting the research event for Faculty Summit, we have also been conducting annually a PhD production study along the same lines as the CRA study which is done in US. We've been doing this every year. The latest study, which is done by Dr. Gautam Shroff from Sachin Party of TCS Research, we found that there are around 224 PhDs which were used. Not enough, but we have miles to go before we accomplish any decent idea of the number of PhDs in computer science. This is an annual feature which ACM India has been carrying out, and we want to make this a standard feature as an input to the stakeholders. It could be computing fraternity, it could be policy holders in government, it could be think tanks which work on improving innovation climate in India. All of them can be consumers of this kind of a study, and we will be rolling out the next study very soon. Then, in continuation with the theme of endorsing research, we, along the lines of the Global ACM Dissertation Award, highlighting the best PhD thesis produced in the year, we have created a very successful ACM India Dissertation Award, and we were lucky to have a generous sponsorship from TCS. They have been supporting us for the last 3 years, and they have agreed to support for the next 3 years. Thanks to TCS for that. So what is done is it recognizes the best PhD dissertation in CS and related areas over the last 1 year from an Indian institution. It consists of a jury which is eminent computer scientists. This year, the jury was headed by Dr. Amit Dawar, University of Cambridge. We had 10 nominations from different institutions across India, across different areas, and we had a jury of 5 computer scientists chaired by Professor Amit Dawar. Award will be presented today, and we'll have a presentation in a little while. Award for 2014 was won by Vijay Kasen of IIT Bombay, honorable mention to the CMI. 2013 went to Dr. Ramprasad Satarshi, CMI. Then award of 2012, which is the opening award, went to Uttam Mehta of IIT Bombay, honorable mention to Srikant Srinivasan. And we hope that this continues the stature of doing a really good PhD thesis right here out of India, and we really want to honor cutting-edge research, good research in computing happening out of India by virtue of this award. ACM, as I mentioned, has been very vocal in getting international conferences to India and to promote local conferences in a big way to advance computing as science and for professionals and students in India. For example, in recent past, we had the annual ACM India Compute Conference at ABS. We hosted the second time AppSec, which is an international conference in software engineering, Asia Pacific Software Engineering Conference in Delhi in December. We are having the upcoming conference called CORDS by the KDD India, which is IKD, ISEC 2015 in February by ISOF, which is ISOF India. All of you are welcome to look up these conferences and make sure that you attend one of these. These are the conferences that are happening right here in India and of international standard. So invite them very strongly. As we speak, as a community, we are also making effort to get international events to India, like we did for AppSec. Similarly, I'm seeing that this year we have the marquee databases and VLDB which is happening in India. So I'm hearing from Gautam that they're planning to get KDB to India very soon. Even from software engineering, we're trying to get ICSME somewhere in 2017, maybe even models, which is on the operating conference. So from a community perspective, this is an open call to researchers in India to reach out to their global brethren in their specific SIGs and see how they can make use of the offer from ACM India to host conferences right here in India, and we will be there to support them. Recently, in 2014, we had ICSI for the first time held in India, and POPL, which was held first time in India. We have been hosting a series of international conferences in India, and we will active support of that. While we are on the topic of conferences, in order to support good publications out of India, ACM India has tied up with IARCS, which is the Theory Computer Science Society in India, and we provide generous travel grants to students who are unable to travel for conferences abroad. So I put the conference request, travel request through a simple check about standard of the conference where the event is being held and what is the stature of the kind of conference and what is the request for. Is it for attending or is it for actually presenting a paper? We typically encourage people who are presenting a paper and require travel to present their own research. So we have had good number of requests across India. We've been actually supporting IRCS along with us, and as recently as yesterday we have approved 15 lakh grant from ACM India to support more number of students. And give a representation of travel requests supported last year. If you see these conferences which have been supported for travel from India, they are no less than any international stage conferences. Let's take an example of programming language, Atlas. If you look at artificial intelligence, AI, just name an area and we have some of the best conferences where Indian research is being showcased. So this makes me proud that all this is happening right here from India, and it's Indian researchers who are producing this kind of international caliber research. And so it is our endeavor to advance this more and encourage more and more of you to produce more research outputs, become PhD students, produce more and more outputs. In terms of another dimension where we are very active is education. We have been here from TCS is heading a committee on education. We've been very aggressive on taking a stance on how we should change the curriculum the way it is currently practiced in India. Across all levels, it could be a tier 1 institution, tier 2 institution, tier 3 institution. There is a huge gap in terms of the need for the industry or the research community to make use of the current undergraduates because of the gap in the curriculum, the gap in the pedagogy. So ACM India Education Committee is working on several dimensions. We had a massive curriculum workshop in April 2015 in Pune. We invited Mehran Sahami, who is the chair of the ACM 2030 ACM CS curriculum from Stanford. We had a very exciting 2 days discussion on how the CS 2030 curriculum can be customized for Indian needs. So we have actually a pilot going on with the 6 CSC committee under Abhijat and I think Madhavan. They are looking at how this curriculum can be adapted for Indian situations, and they are going to roll out special workshops starting October 16 across India. So if your university wants to change the syllabus, reach out to Abhijat. He's here. He's going to help you identify how ACM 2030 curriculum can be adapted for Indian needs. Similarly, there are several plans for the education committee. One of them is the computing science education workshop which is going to held along with October 31st at Compute, which was held. It was basically a brainstorming event for understanding what are the different areas in which we need to change the education. It could be curriculum, it could be pedagogy, it could be CS levels. There are several programs going on the school levels, there are several MVPs they plan. So as you see, alongside research, education is another big vertical for ACM India. We really want to be big in that, and we really look forward to taking this message to each of you. In your college, you should take a step forward in adopting CS 2030 curriculum, and we take our help in making sure that you get access to the resources which are needed for customizing CS 2030 curriculum from your university. This is the 2015 event Goa. We had Upcroft, we had Susan, we had Professor Berkeley, good time last year at Goa, and we hope to have similar time today here at Trivandrum. So, while we do that, we also have a lot of respect for chapters. As I said, chapters are the lifeline for ACM. What we did is to encourage more activities among chapters, at least among student chapters. What is done is we've done a Best Student Chapter Award from ACM India. We got 17 nominations this year. We have evaluated them on the basis of multiple criteria by independent panelists, technical events, community services, chapter website, membership. So this is something we're going to announce towards the end of this working ceremony. Steps forward, we continue to deepen and enhance the breadth and depth of current ACM India activities around research, chapters, education, initiate newer initiatives, specifically from research board perspective, look at possibilities for new SIGs. We have 3 SIGs, I6, CSC, IKD, ISOC. If any of you have interest and you have a reasonable community across India of researchers, it could be databases, you may start looking at getting SIGMOD to India or something like that. So please be on the lookout for potential for new SIGs. So at this time, I'm very proud to announce that next annual event is also in a very glamorous place. It's historically the oldest city in India where we have heritage, a rich heritage of culture. It is Kolkata. It's in the eastern part of India. For those of you who have not heard of it, it's the capital of West Bengal. These are the famous monuments there. There's the Howrah Bridge, there's the Lakshmi Temple, there's the Victoria Memorial. So, on behalf of Navin Chakti, who is here, the local organizing chair, I appreciate if all of you make it to Kolkata next year and not mind the wonderful food. I think all of you are invited to enjoy the beautiful Bengali food next year. So, with that, I stop here. Visit India.acm.org for more details and invite all of you to become ACM members. By the end of the day, you should make a determined step that I will become an ACM India member, and for your college, open an ACM student chapter. Thank you.
Thank you, sir. Thank you very much. Now, I invite ACMW India Executive Council member, Dr. Arati Dixit, to talk a few words on ACMW India.
Good morning, computing brothers and sisters. A warm welcome for today's event, annual event. It is indeed a pride and privilege to speak on behalf of ACMW India Council about ACMW. After a great introduction from previous speakers on the dais about ACM, I would like to continue some discussion on ACMW in general. So ACMW actually is a women's council of ACM, and this is the chair as Valerie Barr. And regarding the mission of ACMW, it supports, celebrates, and advocates internationally participation and full engagement of women in computing. And regarding ACMW India, in 2010 it was established as a standing committee of ACM India to fulfill ACMW mission in India. And the current chair is Shira, and the aim of this particular council is to provide support and facilitate the women in computing in order to support social and professional support, technical growth of women in organizing invited lectures, seminars, workshops, and also to provide a platform to share information, resources, ideas, and experiences. And last but not the least, encourage participation of women in computer-related studies and researches. In fact, all of us have heard about Curie Award, I assume. How many of you have heard about Curie Awards? Great. I see very nice hands. So this award has been given since 1966. And we have some faces and names on the screen with about approximately 50 Turing Award recipients. we see 2.5 women. 2.5 because Shafi was received the award along with her partner. So this is one scenario. The second scenario is, if we take into account the women in computing, especially in India, you see the graph here about women participating in different streams of studies, where the blue line shows women in engineering and computing, which of course seems to be at the bottom. But if we compare this with the global scenario, we see that there is a sharp decline of women participating in computing in Western world. Especially if you take the case of USA, it has declined from 37% in 1987 to approximately 17% currently. So this is one aspect. The second scenario is, let us look at India. In India, we have seen nice, slow and steady progress in participation of women in computing, the first one. If you look into the job scenario, the NASCOM published report last year which says that about 24 to 32% are women in businesses in IT, then 34 to 42% are women in business process management services, and about 38 to 40 are entry-level participants. But what happens is, after that, the ratio declines from entry of 27 to mid-management of 14% and 0.9% at the top. So we don't have to worry. It is not the case only in India, but this is global scenario. So why am I discussing this today here at the ACMW presentation? The reason is, we are not with any mood of starting some feminine wave, but we genuinely want to take into account the situation of women in computing. Let me use an analogy here. Say for example, if we have to complete a marathon, and if one of our leg gets hurt, what will we do? Won't we take care of that one leg? We take some therapy, we take some medication, right? In order to make sure that we are fit to complete the race. So similarly, in the computing marathon, if we don't have our second leg, that is women, equally participating, we may not really experience the overall development that we achieve because of the diversity that comes in thoughts from both the genders. But there's another good news with respect to women. According to 2015 BNP Paribas Global Entrepreneurship Report, it says that in India, in Hong Kong and France, there are about 50% women who are participating in the entrepreneurial ventures. That's really good news for us, and it could be a piece of inspiration for all of us sitting here. So there are a couple of challenges as you see on the screen here, like women are overwhelmed, or they have imposter syndrome, or they have social conditioning, or lack of supporting, lack of mentoring, and so on. So what we thought in ACMW is that why not to handle this kind of issues through this platform of ACMW. And let me introduce you to different programs of ACMW. The different programs are Celebration of Women in Computing, ACMW chapters, so Scholarship for Women, and ACNA Lecture Award. So regarding the Celebration of Women in Computing, so usually about 17 to 18 events happen every year around the globe, and it typically sees the presence of 3,000 to 5,000 women attending this, which belongs to students, faculty members, and industry partners community. And it is being supported by Microsoft Research, MSR, and ACM. This has happened in different locations, including Australia, Canada, Cuba, India, Europe, Puerto Rico, and so on. So what are typical components of these celebrations? The typical components are student presentations, poster sessions, work in progress kind of things, then panel discussions, presentations, faculty sessions, some soft skill development sessions, some life coaching sessions, and career fair, and so on. What are possible benefits here for celebrating the ACMW Women's Celebrations? So each year ACMW provides celebration coordinators to attend the Grace Hopper, which we do here also, as it is done at the headquarters level, we do in India also. So we support about 40 members from education or academic fraternity to attend the Grace Hopper India celebration. And also the poster competition winners are given chance to attend the Grace Hopper celebration. And it also gives other benefits, as you see here, use of ACM online PayPal accounts, and also we get some swags which are being shipped by ACM body. Regarding chapters, there are about 90 chapters worldwide, which includes many countries like Denmark, Turkey, Greece, India, Pakistan, Kenya, Saudi Arabia, and so on. And these chapters could be located in a single institution, or they could be pretty much regional kind of chapters. And in this, as we saw in Srinivas's presentation, there are 13 ACMW chapters in India right now. Regarding the scholarship programs, these are awarded to women who are interested to participate or attend conferences. Now, in fact, sort of little good news here is that you don't have to be presenting in these conferences, but still you can apply for the scholarship. And why we do this? The whole aim is to support and to kind of encourage students to move to the next level for this thing. And if we take into account the number of awards, approximately 50 awards are given per year. And these awards can be used to go for national or international conferences. And if you look at the application, typical breakdown is 20% bachelor's, 15% master's, and 66% PhD apply for this award. And out of this, 30% goes to bachelor students, 22 to PhD students, and 48 to PhD students. In addition to this, ACMW members also get a free registration benefit to many SIG events like SIG Access, SIG ACT, SIG Art, SIG Comms, SIG CSE, and so on. And ACMW also is known for giving away the EGNA Lecturer Award. And this particular award celebrates the outstanding woman researcher. And this candidate is every year nominated by ACM Special Interest Group, ACM Special Interest Groups, and the awardee speaks at the flagship conference of nominating SIG, which is SIG CSE. And we are kind of lucky to have one Turing Award winner sitting with us in this event. And we have Jennifer Ryan, who is an ACNA Lecturer Award winner of this year. So it's kind of today's atmosphere is kind of vibrant with the presence of Turing Award winner and ACNA Lecturer Award winner. So let me highlight on some ACM India events. In addition to the goals and mission that we have as an ACMW HQ and ACMW India, we also have a specific goal for India level. We are making an attempt to reach in the rural areas in order to empower unprivileged women and children, so as to support or enable independent and self-reliant kind of behavior. Let me highlight some events that we have done this year. As a ACMW India body, we usually do 4 regional events, and out of these 4 regional events are distributed in the 4 regions of India. And out of this, one is an annual event. The annual event usually happens with a programming competition which is specifically meant for women from undergraduate programs. And this year we have done foreign celebrations like TCWIC, which is PPIT Celebration of Women in Computing, which happened in July, followed by All India Celebration of Women in Computing, which happened in October in Ahmedabad, and regional celebration of women in computing in East and Northwest, which happened in IIT Guwahati. And we also co-presented Grace Hopper 2015, which happened in December. So what is in the pipeline for next coming years? We would like to announce that the next year's annual celebration of women in computing is happening in Trivandrum, which will be hosted by University of Petroleum and Energy Studies, UPS. And some regional events which are kind of pointed out right now are happening in Indore, being done by Indore chapter and Coimbatore chapter respectively in the months of March and August this year. And of course will be co-presented for the Grace Hopper conference that happened where students, postgraduate students and faculty members from different universities in Maharashtra state, this experienced presence of eminent speakers like Dr. Abhilankar, Shweta Chawla, Dr. Suparna Bhattacharya, Rashmi Mohan, and so on. So these are the highlights of this one event. The second event that happened is AICWIC, that is All India Annual Women's Event, and this happened in Ahmedabad from 1st to 3rd October. In fact, on 1st October we had a quiz and programming contest that happened, and followed by the prize distribution on the 3rd October's event, which experienced presence of eminent leaders from entrepreneurial background. The theme of this particular event was entrepreneurship and women. So this was graced by Bhagya Soniji, who is the chairperson of Western Region Associated Chamber of Commerce and Industries, Ms. Shweta Chawla, who is head and chief investigator at SC Cyber Solutions, and Ms. Kriti Davar, who is president of Institution of Electronics and Telecommunication. And this was followed by panel discussion on what could be possible career choices for women. The possible career choices, is it academics, industry, research, or entrepreneurship? Let me talk about numbers a little bit here. There were about 177 participants for this event, and which included faculty members, students, professional members, and there were some members from Ahmedabad local chapters. And number of universities showed their presence, as you can see on the screen here, and it was organized by Ahmedabad chapter, Ahmedabad professional chapter. The regional event that happened in Guwahati, the regional celebration of women in computing in east and northeast of IIT Guwahati. Let me talk about the numbers. There were about 77 women participants, and it showed presence from 12 different universities from around Guwahati, that is in the northeast region states. And this particular event was graced by presence of Dr. Valentina Salapura, IBM USA, Ms. Kumar Srinivasan, who was president of Intel India, Professor Sushmita Surkote, and many more as you see on the screen here. And regarding the Grace Hour celebration, the fourth event, ACM is co-presenter of this particular event, and the conference is considered to be the most popular conference for technical women in India. This particular conference was graced by Kim Stevenson, CIO of Intel, and by Rupa Kurpa from Omnia Networks as keynote. Let me talk about the numbers here. The number of participants were 2,300, 88% from industry, 12% students and academia, and there were about 6 unique tracks and a specific special women-only hackathon that happened. In this conference, ACM sponsored 40 students to participate for this particular conference. ACMW India was invited to participate in the Arab Week, that is Arab Celebration of Women in Computing, which happened at New York University in Abu Dhabi, and was lucky to represent ACMW India to participate in the panel discussion on prominent international women in computing organization and venture capitalists on ACMW and global women in computing. So this particular event was, this particular panel discussion was moderated by Fatma Mili, professor Purdue University, and it had presence of the representatives from Turkey Women in Computing, then also from ABI, US, from NCWIT US, from EBI, and also there was representation from venture capital and private equity USA. And me and Maria Chaudhary, we participated in the mentoring session, which was meant for students. So with this, I would like to greet all of you happy computing. You see the council members here on the screen after yesterday's meeting, and would like to urge upon everybody, men and women, everybody, to together celebrate, inform, and support women in computing with ACMW. Thank you very much.
Thank you very much. Now I invite Dr.
distinguished dignitaries, students, ladies and gentlemen. It is a proud privilege for me to address you on this occasion because we have an array of luminaries in computing to share their knowledge with us. As the head of the institution hosting this event, I am immensely proud to be here at this point. I had one request to make to ACM India Council, and it has already been addressed in general by Dr. Srinivas' presentation, because it was regarding the design of curriculum for undergraduate courses, mainly for the country. As all of us know, we are totally confused as to what the next gen abstractions for computing should be. The data is no longer structured in well arranged tables. The data structures as abstractions that we have been teaching and learning are grossly insufficient to handle the data that is around. The computing, it's very unclear as to whether computing should go to the data or data should go to where computing happens. And the network is visible, invisible, ubiquitous, pervasive, and you are also part of the network. So it puts all of us in confusion when we are sitting in bodies designing the curriculum for next gen computer scientists. So my request is that when we look at CS 2013 curriculum to customize to the requirements of the country, there should be a mechanism to drive the curriculum, because if you look at the institutions in the country, not many of them have the privilege of being autonomous. So these are all regulated by some mechanisms. Universities are related, universities or something. But if some sort of reference is put by some regulatory bodies, maybe AICT, I'm not sure. But if something like that can be done, when industry, academia, everyone works together, there should be some reference for us to look at. Like if it is a data sciences course, how do you build that course systematically for it to be effective, not only for 5 years, 10 years, 15 years down the line. So I see this as a significant step that ACM India needs to address from an academic perspective, because I am more than an administrator, I am a professor in computer science. So from my personal perspective, I feel immensely privileged being able to listen to such a galaxy of speakers whom I have extensively read as a student and researcher. So I thank ACM India for choosing Trivandrum for organizing this event. And I should also make this point here. We have not been able to, ACM as a professional body has not been able to penetrate as much as IEEE did in the country, and especially in the state, where in IEEE we have a lot of volunteers and everyone, but computing community of the state has not recognized the value of ACM as it should have done. So we need to do something towards that also. As the head of an institution like IIIT, I am very happy to volunteer our institution's willingness to take such steps forward. I wish all the participants a great day ahead, and I believe that this day will trigger the spark in all of you to become ACM members, as Dr. Srinivas put it, and also be with ACM towards this journey for advancing computing to the next millennium. Also, I see a lot of women here who must have really been empowered by the previous talk. Wish you all success, and I thank each one of the members who have been part of this event today, and also Dr. Sabu for having organized such a wonderful event at Trivandrum. Thank you.
Thank you. Award Declaration and Presentation. The award recognizes the best doctoral dissertation from a degree awarding institution based in India for an academic year. And the award is accompanied by a prize money of Indian rupees 2 lakh, and the winning dissertation will be published in ACM Digital Library. This award is additionally supported by Tata Consultancy Service Limited, TCS, as founding sponsor of ACM India Doctoral Dissertation Award. I invite Dr. Supradeep Chakrabarti from IIT Bombay to deliver a presentation about ACM India Doctoral Dissertation Award and the declaration for the award in the year 2016.
Good morning, everybody. As Srinivas mentioned, the ACM India Doctoral Dissertation Award is given to the best doctoral dissertation produced over the last 1 year. The term is from August to July of the next year, and this was approved by the ACM Awards Committee in 2011, and Tata Consultancy Services has been very generous in sponsoring this since its inception. This is the 4th year of the award, and this year we received 10 nominations from 7 academic institutions from across the country. All the nominations were reviewed by a panel of computer scientists over a period of 3 months, and this finally led to the selection of the winner that will be announced today. So this is roughly the process that we follow for selection of the winner. The call for nominations went out sometime in June 2015, and it was sent to all PhD awarding computer science and engineering programs in India. The nomination process was the same as that for the ACM Worldwide Doctoral Dissertation Award. So the material that needs to be submitted is the same. The jury panel for the ACM India Dissertation Award is separate from the Worldwide Dissertation Award, and this year we had 5 distinguished computer scientists from around the world. It was chaired by Trivandrum, who is here with us today. So this is the jury we had this year. Professor Trivandrum from Cambridge University, he chaired the jury. Professor Neeraj Shah from Princeton University, Professor Pravin Zadi from Cornell, Professor Jeffrey Walker from UC San Diego, and Professor S.K. Vishwanathan from University of California, Santa Cruz. So jury members reviewed all the dissertations, and they also sought reviews from external experts over a period of 3 months. And after all the reviews were obtained, jury members were asked to champion cases that they thought were worthy of the award. There were several discussions over email to to eliminate the non-contenders and identify the deserving candidates. And finally, the chair sought feedback from all jury members to ensure that everybody agreed unanimously on the winner. And the winner is, we have only one winner this year, so I'm sure the winner is Dr. Aritra Hazra from IIT Kharagpur. He's joining the graduation for his doctoral dissertation titled Common Methods for Architecture, Power Management Verification and Functional Reliability Analysis.
Now I invite Dr. Gautam Shroff, Vice President and Chief Scientist from TCS Innovation Labs, Delhi, and Dr. Alex Wolf, ACM India President, and Dr. Srinivas Pathanabhani, President of ACM India, Dr. Anuj Davar from University of Cambridge to come forward to the stage and present the award to the winner. Thank you very much. Congratulations to the winner. And I request Dr. Gautam Shroff to talk a few words in this occasion.
Congrats, Aritra. This dissertation award is part of our efforts to improve the numbers and quality of PhDs in computer science. As many of you might know, but many of you might not know, there are so many young students here. We support more than 200 PhD scholars in India entirely from TCS, and we will be supporting another 200 over the next 4 or 5 years. We have a process of 40 per year being selected, and the dissertation award is on the quality side. And I really look forward to the day when the ACM India Doctoral Dissertation Award winner is also the ACM Doctoral Dissertation Award winner worldwide. Thank you.
I invite Dr. Aritra Shroff to talk a few words in this occasion.
First of all, I'd like to thank the ACM organizations to select my thesis as the best dissertation. So I thank all the jury members who have spent their time in evaluating it and finally converging that my thesis is worthy of this award. And I thank my supervisors. I did my PhD from IIT Kharagpur, so I thank Professor Pallab Dasut and Professor P.P. Chakravarti, who were my supervisors during the years of my PhD. I also thank my family, my wife and my friends to give me support and encouragement, and above all the patients over the past 4 or 5 years during my PhD. So I'm very glad and I'm honored to be seated in this auspicious ceremony. Thank you.
Thank you all. I request the dignitaries to be seated. And next we have the ACM India Best Student Chapter Award Declaration. I invite Dr. Shekhar Sanchabhage, ACM India Chief Operating Officer, to declare the award.
Good morning, all of you. As mentioned by Dr. Srinivas, we received around 17 nominations from different student chapters of this award. And the period was calendar year 2015. We evaluated them on 4 criteria: technical events, community services, chapter website, and the membership members. And we have around 8 juries who actually helped us in evaluating all these chapter reports. They were all from the officers of professional chapters. May I now invite Dr. Srinivas and Alex to give away the awards.
I request Dr. Alex Wolf and Dr. Bobby Scarrow to come forward to the stage and present the award.
So the runner-up award for Best Student Chapter for 2015 goes to MIT University.
Congratulations to the winner. In the absence of the winner, I request our volunteer to collect the award on behalf of the winner.
And the Best Student Chapter for 2015 is Beats Pilani, Beats Pilani Rajasthan.
Congratulations to the
So Beats Pilani actually is winning this award for the third year in succession.
Thank you, dignitaries, and I request you all to be seated.
Let's begin with the star attraction of today. We have amongst us an eminent researcher, a Turing Award winner, a pioneer in artificial intelligence, Professor Edward Feigenbaum. He was born in Weehawken, New Jersey in 1926. He holds a Bachelor of Science in 1956, PhD from CMU. His dissertation was supervised by the famous Albert Simon, and he has explored a pioneering computer simulation of human learning. He has contributed a lot of interesting research contributions to artificial intelligence, and is probably known as the father of expert systems. He founded the Knowledge Systems Laboratory at Stanford University. He is currently a professor emeritus of computer science. There, in 1994, he received the ACM Turing Award. From 1994 to 1997, he was the chief scientist of US Air Force. He is a member of the National Academy of Engineering and the Management Academy of Arts and Sciences. Without further ado, let's invite Professor Edward Feigenbaum. A big round of applause, please.
Thank you very much for that introduction. I think in all honesty, the real star is the student audience here, which is really amazing. So I'm very happy. And I will have some words of advice for young scientists at the end of my talk. I just need to ask, is this too loud? So I also, as many people did, I want to thank the organizers of this event. This is really an excellent event. And then I also want to thank the people from ACM headquarters who came half the world away to this event. They do so much. They're really the engine that makes ACM work. So I want to thank them for all that they do for not only India, but for the rest of the world. Those of you who were at the event last night, you saw for me, because I had this week, I had my 80th birthday. When you get to be 80, then you get the right to have a certain perspective on computer science, and in my case, artificial intelligence. I began my work, as was just mentioned, I began my work with Herbert Simon in 1956, at the moment, you might say, the moment of the birth of artificial intelligence. The first AI program, which was then at a place called Carnegie Mellon now. It was called Carnegie Institute of Technology at that time. So it's been a long time. And 1956, so we are now at the 60th anniversary of the birth of modern AI. And I want to engage in a kind of summing up of how I see where things have laid out in artificial intelligence. And I've summarized this in what I call spectra, simply one-dimensional presentations of some things about artificial intelligence that may give you a perspective on where we are and some ideas about where to go next. Those spectra are what I call the cognition spectrum, namely the spectrum of tasks that we consider to be intelligent behavior. The second is the knowledge versus search spectrum in the methods for accomplishing intelligent behavior. And the third is what I call the what to how spectrum of how artificial intelligence fits in with the remainder of computer science and has always fit in with computer science. I, in fact, discussed the what to how spectrum. It's the main part of the theme of my Turing Award speech that was printed later in the communications of the ACM. And then what I'll do is, from these spectra, I'll draw some lessons in the form of advice to all of you younger people in computer science and IT. Before I begin to discuss the cognitive spectrum, though, I want to mention my own first introduction to Indian IT. I was a young professor moving from UC Berkeley, University of California, Berkeley, where it was my first job, to Stanford University, where a computer science department was about to be established. And when I say that, I mean that the word computer science had only been used for departments in universities only once before by Purdue University. And we were going to, Stanford was going to establish the second computer science department at the end of the first week of January 1965. So I arrived at the beginning of the week, and I had one colleague that I knew very well, who was responsible for my being hired at Stanford. That was John McCarthy, one of the founders of artificial intelligence, also a Turing Award winner. But I didn't see John when I first came down to the campus that Monday morning after New Year's. But I went into his laboratory where he was doing, at that time, he was doing research on timeshare. And so there was a small machine there, actually a Digital Equipment Corporation, a PDP-1, early timeshare system that McCarthy had designed. And there was nobody in the laboratory except one person who was this very thin Indian person, and a graduate student. And I got to talk with this graduate student about what he was doing. He was looking at the screen of the PDP-1, big display, and he was looking at speech waves. And he was experimenting as to whether the zero crossings of the speech wave would be indicative, diagnostic of what was being spoken. McCarthy was a brilliant computer scientist, but he didn't really see his PhD students very often. So I was the only other AI person there in the department, so I would interact with this student a lot, just giving him feedback about what he was doing. Not that I knew much about speech understanding, I did, but anyway, that student got his PhD 1 year later on the first speech understanding program. And that student went on to Carnegie Mellon. That was Roger Eddy. He ran the speech understanding, the National Speech Understanding Project. He then founded the robotics laboratory at Carnegie Mellon. He was the first dean of the School of Computer Science at Carnegie Mellon, and of course, he won the Turing Award in 1994, Turing Award. And to use the terminology that was used earlier, I don't regard him as a 0.5 Turing Award. He's really a 1.0 Turing Award. And Raj was the one who introduced me to some of you in the audience, who I later met as representative of the growth of the computer science in India and the information technology in India. I got to stay away from this microphone. There's too much feedback. Okay. On to the spectrums of behavior. When we use the term intelligence, we mean a very broad spectrum of behaviors. Hear that ringing? That's too loud. If someone can turn that down, that would be very helpful. I know that I was sitting up in front before, it was bothering me a lot. So I know that I don't want to inflict it on you. So here are some examples of behaviors. Unfortunately, I should have brought a laser pointer, but I didn't. On the one hand, when we think of something that's intelligent, what's the most intelligent thing you can think of? Well, maybe Einstein, or maybe Aristotle, or Johann Sebastian Bach. When NASA launched the space vehicle that was intended to travel past all the planets and exit the solar system, that was the Voyager space vehicle, they put a disc engraved in metal in case any civilization would ever find this spacecraft. And the disc had pictures of diagrams of what people look like and other examples of knowledge about our world. And one of the things it had on it was the music of Johann Sebastian Bach. And they chose that as being, in the words of Stephen Jay Gould, this is the greatest we have been able to do. So sometimes we think of those behaviors as being intelligent behaviors. But every day we do we recognize scenes. I look out at the audience and I recognize that it's an audience. I look at this and I recognize it's a computer, and that's a bottle of water. And that's scene understanding, and it happens just like that. It happens so fast that we have no idea what processes are going on. We can't explain them. They happen so fast. Now, when I use the term fast versus slow, I'm borrowing that technology, those terms from a wonderful book by the Nobel Prize winner, Nobel Prize in Economics, Daniel Kahneman, a book called Thinking Fast and Slow that he published about 3 or 4 years ago. And here you see that the truly astonishing behaviors that we do, the great discoveries, the great mathematical theorems, the inventions, those take place in the time of minutes, hours, weeks, months, years. For Einstein, general relativity was 10 years in the making. But when we talk about these kinds of perceptual activities, we're talking about milliseconds. Recognizing that that's a bottle of water is done in milliseconds. So that's what Kahneman would call thinking fast. Then we have other examples I've listed here. Of course, the one I've been mostly involved with. Oh, there is a laser pointer. How do you do that? Do it in the middle. Ah, that's great. The one that I've been mostly involved with is expert systems. And there, we're not talking about milliseconds. There, we're talking about typically the solving of problems with using modern computers in the time of seconds or sometimes minutes. Here's an example of a very high-level behavior which astonished the artificial intelligence world and also the computer science world. The IBM program Watson, just a few years ago, beat the best players on a television game called Jeopardy, which is a rather difficult game involving a tremendous amount of, first of all, world knowledge, and second of all, extreme quality in natural language understanding, including things like puns and other strange uses of the language. Now, in Jeopardy, they don't allow the contestants to press the button for announcing an answer for 3 seconds. And what you have to do is get your finger on the button, and if you know the answer, press it down in 3 seconds, and you get a shot at getting your answer. And in the case of Watson, a typical number of seconds it needed to get the answer for itself was about 2.5 seconds. So it had to wait a little bit until the 3 second time had elapsed. So actually, that's a little bit of, this is in milliseconds, this is in seconds, and that was a really amazing performance. Now, expert systems are programs that model human expertise. So the characteristic that they have is that they, if done well, they are extremely high performance programs. They behave like the best experts in the world in particular narrow areas of work. For example, medical diagnosis. But even that's too broad. Some of the better programs are even narrower than that, like medical diagnosis of infections. The other characteristic of expert assistants is that they are very brittle, in that if you go outside of what it is they know, then their behavior goes from world class to absolutely stupid, just like it went over a cliff. So that's the characteristic of expert assistants, and it led to a generalization that in the knowledge lies the power. That is, to the extent that programs are high-performance programs in AI, it is because of the knowledge that they have of the world, not underlying, not because of the power of the inference methods that they are using. We had numerous experiments that show that increasing the power of inference did not lead to higher performance in the behavior of these expert systems, but increasing the amount of knowledge about the domain of the expert system has a very substantial improvement in the performance. Now, recently we've seen some actually quite startling developments in artificial intelligence in the area of what are called personal assistants. The first one being Siri. Siri was the outcome of a very large U.S. government program in the areas of in artificial intelligence and particularly in machine learning. But those of you who have iPhones are quite familiar with Siri because you just punch the thing and ask Siri any question, and about half the time it gives you the right answer. And about the other half the time it points you to websites which generally do have the right answer. Cortana is a similar one from Microsoft, whose characteristic is that it leads you more to websites than it does giving you answers. And Google now is, for Android phones, is about the equivalent of Siri. In speech understanding, of course, the key name, historically speaking, is Ronald. But one of the outcomes of the U.S. National Speech Understanding Project was a speech project out of Stanford Research Institute, SRI, which led to the formation of this company, which later bought another company that started by Ray's students, a company called Dragon. And now, every time that you ask a smartphone something in speech, that request is forwarded on to Nuance in the cloud. And Nuance comes back with the speech interpretation. So it's a tremendous business. One last thing I want to say about this before I leave this slide. It's very important to understand in the current state of AI that everything you hear about everything that you hear about neural networks and deep learning in particular relates to the subset. There's too much ringing in the room. Can you turn the volume down a little bit? Relates to the subset of cognitive. It relates to the subset, which is the recognition subset of the cognitive spectrum. It's the perceptual subset, not the cognitive subset. It's the recognition, speech recognition, visual recognition, any other kind of sensory recognition. That's what is handled by the neural networks and the deep learning. But no one ever says that you have a neural network or combination of neural networks who will do reasoning about problem solving or do expert systems or any of that. That's important to understand that most of the work in artificial intelligence today is in the recognition areas down here, not in the cognitive areas up here. And I'll have something to say about that at the end. But I just want you to keep that in mind. Whereas historically, most of the contributions of AI were in these areas. I want to just play you a little video of a program where the intention was to model the knowledge of biology that is contained in a advanced high school biology book, textbook, 1,200-page textbook. The one that's most used in the United States for advanced student work in high school biology. And it was an attempt to do what Raj Reddy called for in his Turing Award speech, which is to read text and answer the questions at the back of each chapter. Or in this case, a little more flexibly, answer any question that the student might ask about the chapter. So let me see if I can make this. Now, someone said if I get the pointer to... No, I'm not sure how to make the pointer go there. This is actually a little video, but I don't know how to make it. There we go. That work was done by the Allen Institute of Artificial Intelligence in collaboration with SRI, the same organization that did the Siri work. And that video was a video that won the AAAI Best Video of the Year award a few years ago. Now I want to move on to within the realm of the cognitive tasks, the problem-solving tasks, the tasks of concept formation, and so on. I want to discuss the knowledge versus search spectrum. it's fundamental in artificial intelligence. I'm sorry about the reading, but I have to step away from this microphone. Got to turn the volume down, folks. So, on the one end of the spectrum, on one side of the spectrum, you have the applications, the programs that are knowledge intensive. The best example over the years has been expert systems, where the power of the expert system derives from the knowledge held about the universal discourse. In the earliest days, that's a lot better. In the earliest days of artificial intelligence, the model of problem solving was established, which was a search model in which the problem solver investigated many avenues in a branching maze, a tree of a space, what's called a space of possibilities, pruning that space to manageable proportions using either world knowledge or using what are called heuristics. The great mathematician George Polyak called the art of good guessing to prune that space. The size of the space for almost any problem of any interest to us is enormous. Even for games, the space is absolutely enormous. So, in the early days, what was established was a search model of problem solving. Then came the era of expert systems, and what the experimental results showed was that search was much less important than knowledge. That knowledge was so powerful that it was able to eliminate most of the search needed in a big search space to arrive at good answers to problems. So here are some examples at the these examples here are examples that I'm going to talk about at the search end of the knowledge versus search spectrum. And these are all examples at the knowledge end of the knowledge versus search spectrum. Dendrol was the original expert system, forming hypotheses about organic chemical molecules from data that was seen in a physical instrument called a mass spectrometer. The search space for the organic molecules that were being investigated here happen to be collections of molecules of carbons, nitrogen, oxygen, and hydrogen. Search spaces here would easily run into 10 to the 20th, 10 to the 40th, 10 to the 60th number of alternatives for larger molecules. And yet, when a chemist thought about such problems, the chemist would examine only a few dozen or a few hundred molecules based on knowledge of chemistry and knowledge of the subdomain of mass spectrometry. Then came a program called Dendrol. If Dendrol was using the knowledge of chemistry in order to solve these problems, how did the chemist get that knowledge? Well, if you ask the chemist will say, I saw a lot of examples of this. So in Dendrol, we we took thousands of mass spectra for a particular family of molecules that I'll give you the chemical name for it, but you don't need to even remember it. It's called ketoandrostanes. And we set up a program which did a lot of search over the space of all possible rules that might form a theory of mass spectrometry for that family of molecules. In other words, we were up one level. We're up at the learning level, the meta level. And that space would be pruned by all the data that we have from the examples. Well, Metadendron was the first program using that combination of data-driven and search-driven methodology. Metadendron was able to infer brand new rules of chemical mass spectrometry that were published actually in the Journal of the American Chemical Society, not published as an AI thing, that look what AI did. It was published as pure chemistry. In fact, all we did was to give a footnote on the first page that said that this was done with the assistance of a computer program. We didn't even give the AI any credit except for the footnote. Here's another example from Microsoft Research and used in the Bing search engine. In the Bing traffic navigation software in their Bing search engine for routing drivers around traffic jams on major highways. If there's a traffic jam, you could wait an hour or more in the traffic jam before you were able to go through. So the search engine figures out what are some alternate routes for you. Get off that highway and go through the city streets, and then come out at another place, and then get back on the highway. That program is called ClearFlow. It's part of Bing for traffic routing. In order to make that work, the Microsoft people needed to aggregate enormous amounts of historical data for the traffic that would flow on different streets in a city at different times of day, depending on what time of day it was, because of the flow of business and commuting and so on. And originally, it's such a big job, they did it only for Seattle, Washington. Eventually, it was so successful that they were kind of forced to do it for many other big cities in the United States. But you can see the impact of the trade-off between a lot of search looking for routes and the historical knowledge of what would be the best route. I want to go quickly because I see that I'm about to run out of time. Error. Error is a partially search-driven and partially knowledge-driven art-making expert system developed by an artist at the University of California, San Diego, named Harold Cohen. When I first met Harold, he had the idea that he wanted to create a model of an artist thinking about creating a piece of art. And the artist who he wanted to model was himself. He was a very well-known British artist who had come to the University of California, San Diego to help start the art department. He's also one of the world's leading colorists in art, making behavior. Anyone know what happened? So, anyway. So, thank you very much. So, Harold began work in 1975. And that work has been continuous up until the present. And his current expert system is 15,000 rules. Now, when you get 15,000 rules to interact with each other, one rule firing off against an emerging image, because it sees something and it wants to make another addition to the image and so on, you get enormous complexity. The search space is huge for the possible images that can be made by Harold Cohen's Aaron system. And I'll show you an example. I want to come back to, I'm going to return to this slide here and talk about these two in a moment, but let me show you an example of one of these images. It happens that this particular image is a very large one. It hangs on my wall in my home. This was made by Harold's program in 2003, I believe. Here's a segment of this image. I'm sorry about the color, it didn't render quite correctly on the screen, but inside this image, in this area here, is an extremely intricate bit of coloring here, which is phenomenal. It's the combination of all these different reds and pinks and blues and purples and little dots of color that is really astonishing when you see it. Just look up close to it, and it hangs on the wall. So I had a little dialogue with Harold when he visited. It's hanging on the wall, and I said, Harold, how does Aaron select that particular spectacular set of colors and their positioning in the image? And he said, Ed, I simply don't know. Aaron is just a programmer, so I'm sure I can find out. But all the decisions that go into it are so complex that I don't want to go there. I can't figure it out. It's just too complicated. And then he points to that thing I showed you, and he said that, he points to this, and he said that he wouldn't have had the guts to do that. And he's a major colorist, and that was so innovative that it wouldn't have occurred to him to even try that. It violated so many of the rules of ordinary art-making behavior that you might teach to students. And then he said he thinks that by now, that was about 10 years ago, Aaron is the world's greatest colorist. Well, that's really astonishing. It's a combination of the knowledge that Harold knows about making images and putting color on those images, and the search that it takes to generate very complicated images like that. Now, just two more things about this. I want to mention something about the Eurisco squadron. AM is the PhD thesis of one of my students, Douglas Lennon, who worked for a research organization in Texas, but later formed his own company, a research company called Site Corporation, CYC, that specializes in building up enormous bodies of knowledge to do away with that problem I mentioned earlier, the problem of brittleness in expert systems. So his knowledge bases, called common sense knowledge bases, have millions of assertions in there. Well, anyway, Leonard was teaching at Stanford for a while, and he had developed a general heuristic search framework called Eurisco. And he was interested in a game called Squadron. This is an interesting, it's actually called Trillion Credit Squadron. And for credits, you can substitute the word dollars or rupees or whatever. And what you do in this game is you use your money to invest in a navy. You build the best possible navy you can build, given the rules of how to buy things in a navy. And then the other set of rules is how these interact in a war. You go to war with somebody else's navy. The rules are given in a book that's about an inch thick or 2 inches thick. And you have to read all those rules, understand them, and then buy your baby and then play somebody else. So Leonard, what he did was, this was a time when we didn't have a lot of computing, but the first of the Xerox workstations, the Altos and Dorados, these historically important workstations, and the Ethernet was invented. So these workstations were connected by the first Ethernet, and Leonard would, on his way home from Stanford to his house, he would pass by the Xerox Palo Alto Research Center. He had their permission to run this program, playing this game, on all the available machines that were not being used in the evening. And then in the morning, he would come in and he would look at the list. The program had listed the 100 things that it thought was best to do next. And Leonard would select a few for the next evening's run. And then he would, every day he would, so it was a combination of machine search and human, unarticulated knowledge about what would be the best moves in this game. In 3 or 4 months of doing that, the combination of Leonard and his program had found what I like to call a niche in the game, or a hole in the game. In that 1 or 2 inches of rules, there was a logical niche in those rules where if you found it, you could win the game just like that. And when Leonard went to the national championship and he knew what move he was going to make, he sat down opposite another person, started playing, and the person said, "Oh yeah, I see what you're doing. I resign." And then he went on to the next person. "Oh yeah, I see what you're doing. I resign." And so on. And Leonard won the championship. Of course, that made the organizers very unhappy. So they changed the rule book for the next year. And Leonard did it again for the next year. And then they banned him from the tournament. Okay, so that shows that human-machine interaction in AI, with humans using unarticulated knowledge, and the program doing the search. Programs are very good at systematic search. People are not so good at systematic search. That this will be a very powerful idea for the future. Now, this one, of course, is well known. This is 1998, and the IBM program Deep Blue beat the world's chess champion Garry Kasparov in mostly a draw. That is, most of the games in the match were drawn, except for one game where Deep Blue made a spectacular chess move, and Kasparov resigned. So Deep Blue won the game and therefore won the tournament. Now that was an example of where only a little bit of human knowledge was used in Deep Blue's chess playing program. IBM invested a great deal of hardware talent in making Deep Blue as fast as possible, so that it could examine, in Deep Blue's case, not millions of alternatives, but actually hundreds of millions of alternatives, compared with Kasparov, who, being brilliant, and all in chess, not in general, but in chess, and also having seen a lot of chess games in his life, he selected 300 or 400 avenues to search. Not millions. But in any case, in searching in the order of 10 to the 8th moves, Deep Blue found a move sequence that was not the greatest ever seen in chess, but it was highly regarded by chess experts. It took the chess people it took them several months to figure out why that move was so great. And you might say, well, what difference does it make? 10 to the 8th is such a small number compared to the size of the space being explored. Chess is 10 to the 120th in avenues of exploration. How could that make any difference? Well, the reason it makes a difference is that there's a joke which is told in the United States, and I don't know if it's told in India. Two campers are camped by the trail, and they wake up in the morning, and there they see a bear. They're afraid of the bear, and one of them starts to run away, and the other one sits down on a rock and starts to put on his shoes. And the one who's running away says, "What are you doing? Why are you waiting there putting on your shoes? Don't you have to run fast?" He said, "No, I only have to run faster than you." And in this case, the 10 to the 8th makes a big difference because it is, you might say, this program is running faster than Kasparov. It doesn't have to be the world's greatest ever chess player. It has to be just better than the best human chess player. And that's what happened here. Okay, I want to do just a little bit about the what-how spectrum, and then I'm going to conclude with my words of advice. If you look at the history of computing, down here at the how end of the what-how spectrum, you have the lowest level instructions of the computer, either the computer's basic instructions or even in the firmware, you have even more basic instructions down here. And of course, nobody programs in those. You won't ever see that in your life. I mean, you won't even see the symbolic assembly language probably in your life. What you see on the next level of description, either you're doing, like in the old days, there would be the common-oriented business, that's the very software language, COBOL. Or Fortran, or a lot of people program in C, or if you're an AI or language program, natural language programmer, you might use Lisp, or if you're a database person, you might use SQL. And then on top of that, the steps continue to, for example, you might use a spreadsheet. A spreadsheet takes you a significant distance away from how, but you still have to put in the formulas that you want computed in the cells. So you still have to know something about how. Well, the goal of AI out here is the extreme what end of the spectrum, where you don't need to know any of that. At the what end of the spectrum, a human being expresses what it is he or she wants the computer to do, the information processing system. Forget that it's a computer. What needs to be done? And express that in human language with all the subtleties of human language and the knowledge necessary to accomplish that task. Now, the reason that and this is in the history of software development. Now let me tell you, let me make a prediction, and it's going to relate to the what end of the spectrum. About 3 years ago, maybe 4 years ago, a Silicon Valley venture capital person who's actually very important in the history of web browsing, Mark Andreessen, made a slogan, which is quite correct. The slogan was, "Software is eating the world." And that's true. That's why almost everyone in this audience here would be a software person. Well, my prediction is when it's 2020, the slogan will be, "AI is eating the world." And the reason is because of the proliferation of devices in the world. and the users of those devices, what those users know about the use of those devices. Sometimes this is referred to as your grandmother problem or your mother problem. How are you going to get your grandmother to use this thing? How about teaching your grandmother how to use a smartphone? Think of all the things you have to know. Even though the smartphone is supposed to be smart, you still have to know how many touches to do and where things are hidden and how many screens back it is and how do you interact and how do you connect and how do you do that. All those things you have to know. Well, the human race in the Internet of Things is going to get completely fed up with that. What they want to do is express what it is they want to know. And have these programs have the knowledge, be able to interpret their language and have the knowledge to actually accomplish that. That's going to happen because of its tremendous value. And that's when AI is going to be in the world. For you young people, that's where you want to be. You want to be doing those things that express the what and the what to have statement. This is, in fact, the Heidelberg Symposium was mentioned earlier today. At the Heidelberg Symposium, actually it wasn't the Heidelberg Symposium, it was the San Francisco ACM Turing Symposium. Alan Kay gave a talk on computer-human interfaces and said that, and they quote, computer-human interfaces should move to the what to how paradigm. In other words, make the interface of every computer be a what interface, not a how interface. You shouldn't have to know what places to touch on the screen, and you should just be able to talk to the system and have it accomplish your goals. Okay, finally, we get to my advice. So all of you who are not young, don't pay any attention. Just keep doing what you do. My first piece of advice is, where you see a crowd working on some problem, go somewhere else. For example, in AI, if you see 95% of all the AI researchers working on machine learning or neural networks, that's great for them. Go somewhere else. Do something different. Don't go where the crowd is. Another way to say that is, unexplored computer science is really a vast territory. And what you want to do is to avoid incrementalism. Avoid just adding on to a little slice of knowledge. That's just not worth your time. Try to, you're going to go read Thomas Kuhn's book, The Structure of Scientific Revolutions, written in the 1950s, in which he talks about paradigm shifters versus incrementalists. You want to be a paradigm shifter. You don't want to be an incrementalist. Now, when paradigm shifters turn their attention to making money, then they become what are called Silicon Valley unicorns. They're some brand new idea that suddenly upsets some whole field of work. Second thing is, if you want to go somewhere else, I would suggest going back to these cognitive methods that involve massive search. Now, ordinarily, that would, if I gave this talk 20 years ago, that would have been absolute heresy. You wouldn't, or 30 years ago, you just wouldn't even think of that because there wasn't enough compute power around to support efforts at massive AI by massive search. But things have changed. The power of modern computing is absolutely enormous. The data centers that Google runs for all over the world, actually, I think there are more than 30 of them, but each one of them has a couple million computers strapped together. The way Watson was developed was to develop it on a single computer, even though a Watson answer that had to be done in less than 3 seconds took an hour. IBM said that's not a problem. When we get there in the quality of performance, we'll just throw computing power at the problem. So we are in the era of absolutely enormous computing that can support one of these discovery by massive search. So my view is people should start doing that. It's right for important results. And I also would agree with Alan Kay that people working in CHI should explore the what end of the what how spectrum. Now, this relates specifically to you young people, particularly if you're PhD students. Search where you are, whatever institution you're in, you probably pick because it's a pretty good place to be, which means it probably has some very good faculty members or some very good researchers available. Find the smartest of those. If you can, find a genius. Find yourself a Herbert Simon, or somebody like him, or an Alan Newell. Find some really, or Rob Ritt. Find yourself a really smart local genius. Or at least that person should be a great mentor who's also very innovative and deeply knowledgeable about the field. Don't settle for anything less. If you somehow you find yourself attached to somebody else, find a way to get unattached. And if you fail to discover one in that place, change your environment. If you've looked around your own university and you can't find one of those, it's worth your while to find another university to go to, where there is one or more of those people. And my feeling is, in my experience, is that you'll find in universities, institutes, companies, and workplaces, they'll have several of these extraordinary people. Get yourself attached to one of those. That's because there is a tremendous amount of unarticulated human knowledge about how to be a great scientist. And you'll only learn that by apprenticing yourself to some local genius. So let me finish the talk by quoting myself, which is allowed, right? You don't have to give anybody credit if you're quoting yourself. I wrote this out actually 2 different times for different purposes in the communications of the ACM. So I'll just read you one version of it. What I call AI, the manifest destiny of computer science. Now, it says here, I learned the term manifest destiny when I studied American history as a young student. In the early 19th century, when the small population of the new United States extended only to a little bit to the Appalachian Mountains in the east, great visionaries like Thomas Jefferson imagined a USA that encompassed all territories to the far ocean at the continent's edge, the whole thing. That vision, motivating generations of settlers and policymakers, and in computer science you are all settlers, was called the manifest destiny. So AI is the manifest destiny of computer science, the goal, the destination. It's the final frontier of where we are all going. More than any other field of science, our computer science concepts and methods are central to the quest to unravel and understand one of the grandest mysteries of existence, which is the nature of intelligence. Generations of computer scientists to come must be inspired by the challenges and the great challenges of that journey. Thank you.
take a couple of questions.
No, I meant to leave about 15 minutes for questions, and I left about minus 15 minutes for questions, but I would love to answer any questions.
Sir, thank you for the talk. It was very enlightening. And I have just a small question about that combinatorial search you mentioned. Could you please put some more detail on that combinatorial search and how it helps in AI?
So somebody closer will have to give me the, there's too much echo in the room to...
Sure. He's asking
how
combinatorial search is going to help in AI.
I thought I answered that question. I thought that I said that's one of the... First of all, combinatorial search is central to the earliest problem-solving model in AI. That was, for example, the very first AI program ever done, the logic theory program that proved theorems in computational calculus from Whitehead and Russell's Principia Mathematica, was a search-oriented program. And it happened to find the proof of two of the theorems in chapter 2 of Whitehead and Russell that were proved much better by the program than by Whitehead and Russell. And when that proof was sent to by Simon to Russell, who was still alive, Russell wrote back and said, well, why did Whitehead and I waste our time? So combinatorial search is central, but it's been ignored by AI people, first in the era of expert systems, when there was so much knowledge in an expert system that not a lot of search had to be done. And secondly, because not too much computing was available to support huge amounts of combinatorial search. Well, that means it's an unexplored territory. So, that's exactly where you ought to be going, is where there's unexplored territory.
Okay, thank you, sir. Just me have one clarification. How much is too much search? Because where do we draw the line between search and knowledge? Or how do you find the balance? Or is it an AI problem in itself, deciding how much we have to include search in that equation and how much knowledge we need for it to work?
Yeah, good question. I think it's not useful, sorry, shouldn't stay so close to the microphone. It's not useful to put a specific number on that. Because there's always a mixture of knowledge and search. For example, I refer to the IBM Deep Blue program of 1998 as I gave the implication that it was largely a combinatorial search methodology. But actually, IBM had some chess masters working with them, and there was chess knowledge in that program. That chess knowledge was not extensive, not as much as Kasparov had, and it's not as much as would qualify to be an expert system, but it was enough to defeat the 10 to the 120th and produce a brilliant move with just 10 to the 8th. So anytime you find that you're at the edge of where the combinatorics meets the limits of computing, then sprinkle in some knowledge of the domain. Now that will constrain what you find, but you have no choice, right? Now another thing we computer scientists should do is take the lesson of the physicists and the astronomers. When they want computer time to simulate the galaxy, they go to the local supercomputer center and they ask for 3 months worth of supercomputer time. We don't even ask for 3 minutes of supercomputer time. Well, we ought to imitate them. and get the supercomputer centers working for us?
I have a slightly more general question. 6 months ago, the Economist had artificial intelligence on its cover. Okay? So 6 months ago, the AI was on the cover of the Economist. 2 months later, Stephen Hawking, obviously great physicist, but probably didn't know enough computer science to say that every AI is a danger. And then there are other articles talking about how AI is taking over jobs. And when you say AI is our manifest destiny, so what's your view on how it's going to transform life, jobs, and everything else? Apart from being a manifest destiny intellectually, what is it going to do to society?
Could you summarize that question?
Yeah, so there's been a recent apprehension by Stephen Hawking, Elon Musk, and all these guys.
Oh, yeah.
Unsafe AI.
Right.
So he's kind of saying.
That's great marketing by Musk and Hawking. When you have Musk and Hawking saying that you guys are going to be terrible, that must mean we're really good. Right? Because we've spent all those years fighting off people who write books about what computers can't do. But anyway, what was the question?
The question is about how AI is going to affect jobs.
Oh, jobs. Thanks. So now that I think the narrowing of the question that when Hawking and Musk made their giant pronouncements about how evil it was all going to be, it was not a narrow view, but a narrower view is what's the effect on work. And that's a real, I'll go back to that's it. So, I think that I have to answer this as a technologist and someone who knows a little bit about technology history, but I'm not an economist. But if you want to read an economist's view of this, I would suggest a book. Now, I'm going to give you a name that is impossible to pronounce, difficult to pronounce, impossible to spell. So I can't tell you how to type it into Amazon. But it's Bjornson and McAfee. And it's called The Age of the Brilliant Machine, I believe is the name of the book. There's a companion book, that was 2014. There was a companion book in 2012 in which they explore that whole subject. But the gist of it is that we used to say that the jobs, this is in the past, we would say the jobs that were threatened were the jobs of the white-collar worker, the clerks, the lawyers, the doctors, anyone who does thinking, because expert systems were performing extremely well. And that was the work of the professionals, the white-collar workers. But the jobs we thought that would be protected were the jobs using skills that mankind inherited from evolution, namely wonderful eyes, wonderful ears, manipulation, touching, anything that had to do with perception and locomotion. You'd never put that out of business. It's difficult to put a gardener out of business, for example. But that's not true now. The pace of robotics is picking up. Where the quality of robotic activity is going to lead to those jobs being automated also. So I think there is a really big job issue, I think. But actually, when you read articles about it and have real data in them, it shows you that the more we have introduced these kinds of technologies, the more jobs we have created rather than the fewer. So it's counterintuitive. The data is saying something else than what Jordan or myself or people like that would think. but it's the central issue. But another way to look at it is to say that when my grandfather was working, he was working 60 hours a week as a tailor in New York. And the idea of a 40-hour work week hadn't been invented yet. But 40 is an arbitrary number, right? I mean, why can't it be a 30-hour work week or a 20-hour work week? I thought that's what machines were supposed to be for.
Any more questions? Any more questions?
Thank you for the excellent speech. Again, a more generic question. Does AI work on the premise that I was saying more of a generic question. Does AI work on the premise of structure? For example, we talk about automated cars. Probably would work in an environment where there's traffic rules and follows, etc., and where there's a lot of structure involved. How would you see AI, applications of AI in a place like India? Or have you given any thought about that at all?
I'm not understanding exactly what is it that makes India different from any other place.
Very few traffic rules. Traffic rules. So I'm thinking primarily from the perspective of automated cars, for example. Right?
Autonomous vehicle?
Yes.
Oh my gosh. I didn't even appreciate that until yesterday. Driving down on the road from to here is total crazy suicide. So I thought to myself, now, it's one thing to consider, yesterday I was driving down from near Cochin down to Trivandrum, and it was absolutely crazy on the Indian road. The first thing I did was I didn't watch the road and the driver. I just put on a podcast and closed my eyes. And my wife thought I was sleeping, but I was hiding. The second thing was to consider the difference between Google testing its self-driving cars on the calm, wide streets of Mountain View, California, where they've driven now close to 1 million miles. You notice I said Mountain View, California. I didn't even say Palo Alto or neighboring. They only succeed because they have a tremendous amount of knowledge about Mountain View, California in the program. So when I thought of what I was seeing on the road here, I thought, there's no way we can do autonomous. How can we possibly? I know the limits of AI, and when I see all these big trucks and small trucks and big buses and small buses and truck trucks and big motorcycles and small motorcycles and bicycles and people and animals, I just don't. I think someone ought to take some of those Google car engineers or Audi or Mercedes or whoever is the Toyota, in fact, just set up an autonomous vehicle robotic center in Palo Alto near Stanford. Bring them over here and say, look, do your experiments here. And I think what you'll find is that they'll have an extreme knowledge-based system. But otherwise, very, very difficult to match the quality of what a good driver does. So, how many years would that be? Maybe for America, maximum 10 years, for India 50? That's okay. I mean, we can still make regular